We're going to record this. This is 10-1 alpha. So, what is a parametric equation? A parametric equation is used to graph things that are not functions. So you see this picture on the slide, which fails the vertical line test, but you can graph it parametrically. So what do you have? The outputs are x and y, and the inputs t. So if x and y, I'm sorry, if x and y, yeah, if the two functions have derivatives, then the curve has a derivative. Well, here's what it is. And what happens? It's not a big deal. dy dx is the derivative of the curve. It's the derivative of y with respect to t divided by the derivative of x with respect to t, because the dt's would reduce. The second derivative. To get the second derivative, you differentiate the first derivative. Except what? You take the first derivative and then you divide that by dx dt. So you need that additional step. So here's an example. Find the second derivative. So we want to do dy dt over dx dt. You see that? So dy dt is 1 plus a negative 3t squared. The derivative of this is in the numerator. The derivative of x is in the denominator. 1 plus a negative 2t. But to get the second derivative, ready? That's just what the derivatives are. You have to differentiate this. Get the second derivative, you differentiate this, which would be the quotient rule. What happened? The denominator squared. The denominator, 1 plus a negative 2t, times the derivative of the numerator, which would be negative 6t. Subtract the numerator, 1 plus a negative 3t squared, times the derivative denominator, which is a negative 2. So that's where you're getting negative 6t plus 12t squared, subtract negative 2 plus 6t squared, which would be negative 6t plus 6t squared plus 2. Then what? That all has to go under dx dt, which is what? That's the same thing as multiplying the numerator by 1 over 1 take away 2t. So you would just have that thing cubed in the bottom of the fraction. Not logical? This isn't difficult. Chapter 10 gets to be, there's more to it, but this is 10-1 alpha is very straightforward. So how about this? Let's read this question first. This is for tomorrow, but think about it now. You have this parametric curve. X equals sine t, y equals cosecant t in this interval, 0 to pi over 2. From 0 to pi over 2. What combination do you have of the function going increasing or decreasing with the concavity? So you need the first derivative for when it's going up or going down. You need the second derivative for the concavity. So that's what that slide was about. We'll come back to this tomorrow. But what do you have to know? You have to know the derivatives of the trig functions. So the work, you saw that the work on the PowerPoint polynomials, that was pretty user-friendly. And now the problem gets complicated a little bit because you have to involve the derivatives of the trig functions. Okay? So make a note of this, write the question down, and we will go over this together tomorrow. You're not solving the problem now, you're just writing it down. It is question 48 at the end of the section. So this is what's on the PowerPoint. The derivative, dy dx, is the derivative of y with respect to t divided by dx dt, and there's the second derivative. Let's look at example 2. So example 2 is similar to what you just saw. In fact, it is what you just saw. No, it isn't. Okay. X equals t squared plus a negative 5, y equals 2 sine t. So you want the derivative of this. All right? That's what you're being asked to do. So you differentiate each of the outputs individually, and their ratio would be 2 cosine t to 2t. The 2's reduce out. That's your derivative. For the second derivative, you have to differentiate this cosine t over t by using the quotient rule. So that would take you to the derivative of the denominator, which is 1, post the denominator, which is a t times derivative of the numerator. Derivative of cosine t is negative sine t. Subtract derivative of the denominator, which is 1, times the numerator, which is cosine t. All of it divided by dx over the denominator squared, t squared times 1 over 2t, which gives you negative t sine t, subtract cosine t, over 2t to the third. Okay, it's just a quotient rule. So we're going to pause this now.